this chapter, first we will discuss in which scenario the ICMP protocol will be used, and then the ICMP have different types, okay, different message types, okay, and how are these message types? We will list it, and then explain two most famous network tools, PIN and Traceroute. That is based on ICMP, how it is worked, okay. And how the ICMP is worked. The ICMP can send in messages and then can return messages between different network devices. Okay, of course, ICMP have different message types. Okay, for example, first, the messages for routing informations. For example, in the host, we can configure IP address and then network masks. And then for this device to communicate with other device on different network, should specify the gateway, okay? But in this network, there are two gateways. Gateways router 2, and then this is router 1. The router 1's IP address is 10.0.0.100, and the router 2's address is 10.0.0.200. And then, which gateway should be configured on this host? Yeah, the host can only configure one gateway address. Then, in this device, we configured 100. So, all the packets destination for the other network should forwarding to R1, okay? But now, if host A has a packet destined for this address, that's the 20.0.0.1, then host A did not know this network is behind R2, did not know. So the host A still sending the packet to R1. Then the R1, this is the router. The R1 knows this network is behind R2. So the R1 will sending the packet back to R2, and then the R2 will forwarding this packet to server A. And then this is a process, but in this process, we can see the packet sending to R1 and then R1 sending back. This is not a best route. That's not optimal route. This is a suboptimal route. So the R1 knows this packet going this interface and then going back. So the R1 will sending an ICMP message. This message we call the ICMP redirect message. That means inform the host A that this is the wrong gateway for this network 20.0.0.0 and then /24. Okay, for this network, you should not forwarding to me. You should forwarding to the 200 to R2. Okay, then when host A received this message, then in host A will change the gateway to 200, but only for this network. Only for this network. So when the next time the host A have a packet destination for this network, this packet will sending direct to R2. Okay, not going to R1 again. Okay, this is the one type, one scenario that the ICMP message is used. Yeah, ICMP redirect. Okay, this is the one function of ICMP. Okay, another function, that's the diagnostics. That's the famous tools is the ping. Okay, the ping uses two messages, ICMP echo request and the ICMP echo reply. When the host A wants to test if the destination server exists or not, or is up or down, then you can use ping and then following by the IP address of this server. Then, of course, this is the IP address. Then host A will sending out an ICMP echo request message, and then the network will forwarding this packet destination for the IP address you have specified in this command. Then reached server, and then the server, if this server is up, then will reply using the ICMP echo reply. Of course, if this server is down, then no one will reply. Then the host A knows this IP address is up or down. If up, there's a reply. If down, there's no reply. Okay, this is the ICMP message used in scenario of diagnostic to test, to check if the network is working correctly. Okay, this is associating with the ping application. Okay, this is a command, use the ping. The ping is usually is supported by any platforms, any OS. That's the Windows support, that's the Linux support, and the router, the Huawei's router also support. Okay. Then another scenario, that's the report errors. Report errors. Okay. When the packet from the host A to the destination, to the server, is forwarding in the network, but when in this router, maybe something happened, maybe some error happened, the packet is destroyed, or the link is bandwidth is used up, the link is congested, and then this packet cannot be forwarded again, and then this packet is dropped. Then, if the packet is dropped, this router will sending an ICMP error report to the source. The source is host A. This error report will tell the source what is happened. Okay, this information is destination unreachable. That means in the router, in this router, for example, router 2, in the router 2's routing table, there's no route items for the destination. Okay, then this packet is dropped. Okay, this is the scenario used by ICMP to report errors. Okay, these are three scenarios how ICMP is used. Okay, then we can see the format of the ICMP. The ICMP is carried in IP. Okay, we can see this is the Ether frame, the Ether2 frame. The Ether2 frame, there's a type field that's the 800, and then this value means this is an IP packet. Okay, then in the IP packet, there's a field we have discussed in previous. There's a field we call the protocol. The protocol, the value, if the value is equal 1, that means it's an ICMP message. And then this is the format of ICMP. Okay, the most important part is the ICMP type and then the code. As we can see, the ICMP have different message types to control the route selection, to report errors, and so on. Okay, this is the different types. And then the code. The code is to describe this type. Okay, of course, some type did not need a code, such as the ping, echo request, and the echo reply. But some types, for example, the packet is dropped, then you need to describe the reason. The reason is described in this code. What reason caused this packet will be dropped? Okay, then the checksum to tell this packet is not destroyed when sending from source to destination. Okay, and then other parameters depending on the different types. Some types need some other parameters. For example, redirect. Redirect means you point to the wrong gateway. You need to point to another gateway. So the another gateway parameter should specify here. Okay, this is the other parameters, but it's depending on ICMP type. Other types such as the echo request, echo reply did not need it. Okay, and then we go to the type and the code. This is an example of the ICMP type and the code. Okay, these types are used widely. First, echo reply and echo request. Okay, the type and the code always 0 because echo reply and echo request did not need a code. The type is 0 and 8. And then another type is to report the packet is dropped. Then the code describes the different reasons. Yeah, network unreachable, the host unreachable, and then 2, protocol unreachable, and then port unreachable. And there's different reasons make this packet is dropped. And then the 5 is redirect. Redirect the packet into to different gateway. I'm not the correct gateway for this packet. Then please redirect to other gateways. Okay, this is a 5. Okay. Then we go to the 2 well-known applications. The first is the ping, and another is the traceroute. Okay, the ping just use the echo request and echo reply. And then in the router, of course, in your Windows or in your Linux, you can use ping as the command line interface. And then ping, you can forward directly by a IP address. Yeah, IP address or host name. And then if you specify ping 10.0.0.2, okay, this is the address of router B. Then the router A will sending a ICMP echo request to this address. Then when the router B received, then we'll reply with an echo reply. Then RTA will receive it, then know the RTB is there. This IP address is alive in the network. Okay, this is the ping. And when you're using the ping, you can specify some options. Okay, for example, you can ping, then specify the -A. Then this A is to select the source IP address. You can use the different source IP address. By default, which IP address will be used? The IP address configured on the outgoing interface. Okay, if the router sending this ping, this echo request from this interface, then the source address is using this interface. Okay, if there's other interface and connect to other routers, then if ping this address, then source address will be using this. If you want to change the default behavior of the router, you can specify -A, then the IP address, the source IP address. Of course, the source IP address must exist in the source router, and then followed by the destination IP address. Okay, then this is the option -A, and then option minus C. C means what? The count. The count. Specify the number of echo requests. When you're using ping to the destination, then not only one packet, not only one echo request is sending out to this interface. There's a sequence of echo requests. How many? 5. The default is 5. But you can specify the number. For example, you only want sending 2 echo requests, then specify minus C and then followed by 2 and then destination IP address. Okay, this is the minus C option. And of course, there's others, minus N, minus T. And the minus N means numeric output only. No attempt will be made to look up host address for symbolic names. That means not use the domain name. Okay, domain name. And minus T to specify the time to wait. When the packet echo request is sending out, then the destination will reply. The reply, you should wait sometimes. Then how long will we wait? How long will we wait? The default is 2 seconds. Okay, 2000 milliseconds, just 2 seconds. Okay, wait 2 seconds. Okay, this is some options. Of course, different systems have different options. You can use ping and to check if there's any other options. Okay, and then this example. For example, you just using the default method ping, and then this is the destination IP address. Of course, when this ping, the source address of this echo request message is the output interface of this packet. Okay, then the echo request will send into the destination of this address and will repeat 5 times, and then you can get the information how the size of the echo request, and then the sequence, and then the TTL. Remember the TTL just exists in the IP packet header, and the time to live. Okay, then the time. This time is when the source sending and then reply. Okay, the time when sending and reply. This is the time period. Okay, time. Okay, this is the ping. And another well-known application is Traceroute. Traceroute just to check the path selected from the source to the destination. Okay, maybe in the network there's many different routes. Then you can choose which route is chosen by the packet from the source to the destination. Okay, you can use Traceroute. Then Traceroute, then followed by the destination IP address. Then the path, each router, each packet will, each step, each hop will be listed here. Okay. Of course, the Traceroute also have different options. The A means to set the source IP address, to choose the source IP address. If you not specify this A, then the output interface address will be used as a source. And minus F, that means first TTL. That's the when the packet sending out, the first packet, the TTL to set, the default is 1. Okay, we should first explain how the Traceroute is worked. The Traceroute will list all the hops that this packet passing through. Then how it is worked? The work is based on the TTL value. TTL value. First, the packet going out, the TTL is set to 1. Then, as we know, each router will minus this TTL by 1. Okay, then the TTL on router A will get a result of 0. Then what happened? Because TTL is 0, then router A will drop this packet, right? Then the packet is dropped, then the router A will sending out and sending back to the source an ICMP message. What message? The packet is dropped. The reason is what? The TTL exceeded. Okay, so when this packet is sending back, then the source address, what source address is used? This source address, okay? The ICMP source address, just the first hop, okay? Then the second time, the host A will sending out the TTL equals 2, okay, equals 2. Then router A minus 1, then gets a result of 1, okay? The 1 not exceeded, so sending to the next hop, okay? Then the maybe RTC, okay? The RTC get this packet, okay? Get this packet and then still minus 1, then this value reached 0. Okay, then the RTC will drop this packet and then sending back another ICMP report that this packet is dropped, and then the reason is TTL exceeded, and then the source IP, just the interface sending back this ICMP message. So this interface is the second hop. Okay, so default step by step can list all the hops this packet have passed. Okay, and then minus F. F means the first packet. Of course, by default, the first packet is 0. So the first hop can list it. If you specify the first as a 2, then first packet sending out, RTA will not reach. So there is no first hop, only begin from the second hop. Okay, okay, and then minus M. M means the time to live. That means when Traceroute, what is the maximum hop to trace? Okay, if you not specify, the default is 30. That means when the packet have passed 30 hops away but not reach the destination, then the trace will be stopped. Okay. Of course, there are many other options. Okay, and name, display the host name of the router in each hop. That means because in this traceroute, the report back is the IP address of each source. So if you want to know the router's name, you need to do a reverse command name reservation. Okay, and then the P, the port, the packet sending from source to the destination is by UDP, and then the UDP have a port. If you not specify, there's a default port is this port. Of course, you can specify a port. Okay, and then this is the traceroute result. When you traceroute and not specify any options, just following the destination IP address, then the first hop, then the second hop, then the third hop. And each hop, the source did not sending only one packet. It's sending by default, sending 3 packets. So there's 3 times. This is a delay from the source to the first hop, and then the delay from source to the second hop, and then the delay from the source to the third hop. Okay, this is the trace route. Okay, and then we go to the end. And in this summary, there are 2 questions. Which 2 ICMP message types are used as part of successful ping? Okay, as we know, the ping uses 2 ICMP messages. One is echo request, another is echo reply. Okay, this is 2 message types. Okay, in the event that the TTL value in the IP header of the datagram reached 0, what happened? Okay, of course, the TTL, the router, each router, when receiving a packet, then doing the forwarding will reduce the TTL value. But when the TTL value reaches 0, the router will drop this packet. Okay, yeah, first drop. Then what happened? The router will create a packet, create an ICMP message to report this packet is dropped. Report to the source. Okay, of course, report to the source. That means this in this ICMP message, the destination IP address is the source of the dropped message. Okay, and then the source is what? Source is the router's interface that's sending out this ICMP message. Okay, ICMP message. Okay, for example, there's a packet, this packet, of course, this packet, there's source IP, and then the destination IP. Okay, this packet is dropped, then the router will create an ICMP message. In this message, the destination IP, just the source IP of the dropped message, okay, dropped packet, and the source IP just in the router's interface, which interface sending out this ICMP message. Then this interface IP address will be used. Okay. Yes, this is how the router doing with the packet that the TTL value reaches 0. Okay.